number the wires and you do it one wire at a time. The common is the most common reason your panel doesn't work. You don't just fit parts into a panel where they'll fit. You try to look at the wiring. So if the outputs are on top, I tend to put the PLC at the bottom of the panel. It's an interactive process. Now, once you have the schematic, you then know what hardware you're going to have going in the panel. And that's when you can start to lay out the panel. Now, in the early days, nobody laid out panels in a 3D modeling program. I've been doing it for maybe 10 years, well, longer than that, where I designed all the panels in a 3D and program. And it's helped tremendously because you can get an idea of like, will your fingers fit in the spaces for the wiring and so forth. And so that's made a big difference, and you can kind of figure out how much space. The toughest part is terminal strips. You can go here and get a count off of the schematic of how many terminals you have. It just never seems quite to work out as many as you need. You always wind up adding more. I've seen companies that have a rule where a panel has to have at least 20% of empty rail, DIN rail. And you'll notice I have about an inch right there, and that's it. Okay, and that's not good. But again, what determines the size of the box? Pretty much where it's going. And so you wind up having to figure out how to get things to fit. But the 20% rule is a good one. If you can get away with it, if you're working in a plant where there's no space limitations, having at least 20% is a good idea. Now, it's also a good idea that the 20% is laid out, is in places where it's useful. I had a panel I designed and I sent it out to a vendor to do the wiring for us. And when the panel came back, I was shocked because he didn't think my layout was good. So he rearranged everything. And the space that I had left for additional drives and stuff was taken up by stuff that wasn't related to the drives. And, you know, the customer asked for a requirement to have something go in the future, and he had totally eliminated all the future stuff by moving everything around. The other big thing is laying out wiring in the panel, which is a toughie. You kind of have to, you want to minimize how long the wires are and where they go. In this case, I didn't have a choice. You'll notice that I brought all the wires off the bottom because I didn't want to block the lights. But the output and the inputs are all at the top due to the cables having to come in the top. So I had to go around and up. But in a lot of wiring, you'll see people separate components, and then they have a whole bunch of wire crisscrossing. So I always work at trying not to crisscross the wires. I look at it like this is an older PLC, and the outputs are all in a row here. But on some of the newer ones, the inputs are on the bottom and outputs are on top, and vice versa. So if the outputs are on top, I tend to put the PLC at the bottom of the panel and put all the output stuff at the top. And then the input stuff comes in the bottom. Now, it's a good thing to do it that way for another reason, and that is electrical noise. Outputs generate noise, inputs have to tolerate the noise. So having them separated that way is a good thing. And that kind of sets the way you should be thinking about it. So you don't just fit parts into a panel where they go, where they'll fit. You try to look at the wiring and say, so where's all the wires that are coming off of this thing going, you know? And it's not uncommon to have, 30, 40, 50, 60 inputs and possibly usually about half that on the outputs. So that's a lot of wiring, and you can save a lot of time and a lot of space if the wiring doesn't have to zigzag back and forth across. And that's where the wireways wind up getting full, is that when people don't lay out the panel and the wires have to go all the way around, go around and come down to something, and then something else is going up the other way, all of a sudden you have a wireway over here that's completely full. There's no room. And that's when you start seeing people leave the covers off the wireways and the panels look, terrible. And that's why. So the process of designing the panel, you have to consider what you have to run, how you're going to program it, and then the physical space of the panel, and then the layout of all the components within the panel.
What is the best practice for where to put power supplies?
Power supplies, that's a good question. Power supplies generate heat, and controlling heat is an important part of building panels. And generally speaking, I like to see the power supplies at the top, because the things that are most sensitive to heat usually is your PLC and some other control devices. So putting the power supplies at the top, convection heat, it all goes to the top. Now, in the case of this box, the box had to be sealed because it was in a greenhouse, and the machine was spraying chemicals and water, and so this is like operating in a cloud. When the machine was running, sometimes you could barely see it because it would be operating in a cloud of mist. So one of the things we did here was we put the DC motor controller with a heat sink that's on the outside of the box, so that the heat from this controller isn't heating up the inside of the box so much. And that works really well if you can do it. It's not often that you can do it. Usually you can't do it because it always has to either go through the side or it's tough to do it through the back. I've done both, but that's a good trick for doing. Now, if I had my druthers, I'd have a cooling fan to go out. And usually what you do is you put the cooling fan down in this corner, let's say, and the exhaust up at the top, so that the air is naturally flowing that way, and you're blowing air in and it comes out the top. But of course, then the cooling fan needs a filter, and guess what dies in a control panel first? The cooling fan. So when you can get away without one, it's kind of nice because as I say, the cooling fans die. And recent thing, we've been working with PLCs now that every one of them has an analog, at least one analog input. And in the past, I was using a thermostat that sat inside the panel and turned the fan on and off. Again, fan dies first, so if you don't run it all the time when it's not needed, it'll last longer. Well, that was good, but then one day when I realized I always have an analog input, I realized, it'd be a really good idea to measure the temperature in the box and then let the PLC turn the fan on and off. Why? Well, because if the fan fails, the PLC's aware that the panel's overheating and can give you an alarm message, and if at some point say, no, I can't run anymore, and shut off before there's damage. So I think that's a way better method of doing it.